During software evolution, code files tend to be bloated with multiple responsibilities, leading a lot of problems for code comprehension and maintenance. This is particularly true for header files, which can impact many other code files in a project, thereby slowing down compilation. Developers often need to refactor these files, typically by decomposing a large code file into several smaller ones. To alleviate this burden, we propose an automated tool named HeaderSplit for splitting header files. HeaderSplit is available as a VS Code plugin. After installing the plugin, you could find it by right-clicking on a specified header file. Once you select HeaderSplit, the process of splitting the header file begins. In this demonstration, we will decompose the header file stress.ng. It contains 3006 lines of code and 614 code elements. Here, a code element refers to definitions and declarations of macros, data types, variables, and functions, which cannot be further decomposed. Since decomposing a header file requires information of other code files in your project, the tool also requires the path of your project. By default, the tool would take the root directory of your open workspace as the project path. If not, you can manually enter the project path. You should also assign an expected number of subheader files. It might take several minutes for HeaderSplit to parse all code of the project and generate a recommended decomposition plan. The decomposition plan is presented in a clear and structured manner. It shows how many code elements are in each subheader file and the include relationships among the subheader files. For instance, there are 186 code elements in stress.ng. Stress.ng includes 3 files and is included by 2 files. Here, the names of subheader files are generated by GPT-4o. The tool provides parameters that allow the user to customize whether and which large language model to use for naming. Below the overview, detailed tabs are available for each subheader file. These tabs display which code elements each subheader file contains. If you are not satisfied with this plan, you can return to the previous step and regenerate the plan. If the plan meets your needs, you can click the Confirm button to proceed, and the refactoring will be conducted automatically. Now, let's take a look at the results. The stress.ng file has been successfully decomposed into 6 subheader files according to the plan. Shim-Linux sysinfo contains declarations related to retrieving system information on a Linux platform. Stress definition includes definitions and related constants for stress testing. StressUtils contains utility functions and tools that support stress testing operations. The tool also automatically modified the include statements in other code files that directly or transitively included the original stress.ng. This ensures that the project remains consistent and free of include errors after refactoring. For example, in Core Cupid, the include statement stress.ng has been updated to 2 subheader files, stress.ng and Shim-Linux sysinfo. This update ensures that all the necessary definitions and declarations are still accessible to files without any manual intervention. Overall, the HeaderSplit tool simplifies the process of splitting large header files, making your codebase cleaner and more maintainable. Thank you for watching this demonstration of HeaderSplit.